Right, okay, so there are three basic structures to it. There is one that uses a stack. So that's like how we might solve a maze because we're stupid and we don't use any special thing where you just say, oh, I got to a junction and things. But I'll show you that in a sec. And then there is the A-star and Dijkstra solvers. One that uses a graph, which is what we was looking at yesterday. And then one that uses a more realistic representation, which is a tile set, which is just basically like a grid. But essentially, it's still a graph. It's just different organization. So if I just show you briefly how to use just those two elements. Right, so when you go onto this, you get to pick whether you want to go down Dijkstra or A-star. So I'm just going to pick Dijkstra. And it starts with a blank canvas. You can load. If you select load, it will go into the map folder and it'll show you all the graphs. Okay, there you can load up. So I'll just click on one of those. This is from an exam question. Okay, and there's the graph. Okay, but I'm not bothered about that. Right. You can, if you make a nice one, you can save it as well. All right, so you can create something that you make with Dijkstra and then see how A-star solves it and things like that. But I'm not going to get into that yet. Right, so all I do to put nodes on is I just click. I can move them about later. All right, so I'm just going to show you the basics of this. So move them into position. And then I want to make links, routes. So what I do, on the right, it tells you what the control keys are. So when the mouse is over something, so if I press A to say I'm going to make a join, and then if I want it to be a two-way join, I just press D over the one that I want to join to. So let me just make all these up. So I'm just pressing A to select the node, D to join. Okay, so I've made that little graph. Now the graph doesn't do anything until I set a start and end point. So if I press S to make the start point go with a green ring around it, and say I want to get to C. So I then press E. And you'll see that they get highlighted in magenta. I did it on purpose. Magenta, the hideous colour in the world, and lime green. It is a minging colour. What you see is the Dijkstra layout for tabulating. So this system, what we can do up here, it's currently in manual mode. So what happens is the solver is going to go step by step when you press space. So I'm going to press space, and you can see it's set up the table. It's put everything to infinite. I haven't got an infinity symbol, so I had to put INF. Okay, and then it's going to go through the Dijkstra process, picking the cheapest cost in the open set. So every time I press space, it picks, and it color codes all the other nodes. So the yellow is the current one I've selected, which is A. The blue ones are the neighbors, and you can see that it's calculated the costs. Okay, I've put there what all the neighbors are just because that's one way of like sorting these out in your head so you don't have to like look at the graph again. All right, so it's done those calculations. It's put the parent in for A, for B, E, and D. If I then press space again, it's going to do the next pick. So I can look at this, and the nice thing about it is you can build a graph and you can like say, right, I think this can happen next, and you can check. All right, so it should pick B because that's 257. So it picks B. Okay, it's got a neighbor E, and it's looked at that. There is no cheaper cost to get to E. It will go orange if there's a cheaper cost. This is a bit of a simple graph. Okay, so it's going to now pick again. So it should pick D. So it picks D. Does the cost. C is no better. Okay. Then it picks E, and you can see as they're closed off, they go black. All right. I was going to put X and things, but I thought no, I'm trying to allow you to make really complicated graphs, which is why there's a lot of neighbors listed there. And then it'll finally pick C. And then when it's got to the goal, it'll show you the route. And it does that by going back through those parents. Okay, and it does that in red. Right, so that's what I call dynamic mode. So the distances are set based on the actual physical pixel distances. So if I move this around, okay, I should be able to get different automatic changes to the weightings. But I'm in manual mode. I can actually click this and get it to auto solve. So what it's doing is, as I'm moving this around, it's saying to itself, right, hang on, I'm keep on traversing the route. So you can see that it can change those. All right, so it's actually performing Dijkstra continually. Every frame, it's actually doing it. All right, but it's using dynamic distances. Right, so that's why it says dynamic up here. But if you want to build one for yourself to test yourself, if you put it into static mode, it will use numbers that you choose for all of these. All right, so currently they're default to 10. So what I need to do, I need to be able to change it. If I press P, I can show the arrows to show what directions I can travel. Once I've got the arrows, if I highlight one of the arrows, I can use the minus and plus keys to change the numbers. So I'm pressing minus while I've got that arrow highlighted. I think you can put negatives. I don't know whether I'd stop that. Yeah, of course I did. Oh no, I've broken it now. Don't put negatives in. I did this in a weekend when I wrote it. And actually I was doing something else at the time and I thought, yeah. Don't put negatives in, you'll balls it up. Right, let me run that again. Right, so I'm on the Dijkstra solver. Just make your graph. If you add a node you don't want, just press X and get rid of it. So let me just quickly show you that again. I'll put it in dynamic mode. Into static mode, sorry. Click dynamic in the top. Remember, this graph is an abstract view of a network. The physical distances shouldn't really bear any relationship to the numbers. And the example will try and confuse you like that. They'll have a really long line and put 2. And a really short line and they might put 150. So, yeah, not nice of them. But there you go. Right, in that one, when I put the arrows on, you can see I can only traverse from D to A. That's directed. All right? So be wary of that. If the double arrows are on, then that means you can go both ways. So I'm going to put the distances on. So L and P are your two things. P does the arrows, turns them on and off. So I can turn them. Once I've done the setting, I can get rid of them because they're messy. L gives you the numbers. Okay, right. So I'll put the arrows on. Let's change some of these numbers. I'm actually going to set my start and end. If I put it on automatic, as I'm messing about with these numbers, it will be trying to solve it at the same time. So you can see straight away, as I mess with it, it does it. Okay. If you want it to restart, you can do that. If you put it back on auto, you can press space to work through it. That's it. That's all you got to do. If you want to come out and have a look at A star, do the same thing, pick A star. But I'll talk about that when we do that next week. If you want to look at the tile one's cooler. It pits Dijkstra against A star. So you can make a maze using left click, right click, wipes it out. You can see how hacky this was. I didn't even bother making it the same color as the starting point. Same thing, S makes the start tile, E makes an end tile. If you then put it on it's on at the moment, it's on manual solving. Okay, so if I press F1 to reset, and then I can press space and it will do the search. And this is obviously a bigger graph. This has got 2,162 nodes. Quite a few more than what you could manually put on a graph. But if you want to go into automatic mode, press A and it'll do it for you. It only does one step per frame, so one iteration. So if you want to speed that up, if you press plus down here at the bottom, it tells you how many steps it's making at a time. So F1 resets and you can watch it. Dijkstra's the left. Okay. What's interesting is they both attempt to find optimum routes. They've both got routes that are 69 tiles, but Dijkstra's a bit simpler. It goes, and it might be that when you do the weightings, turning costs. There might be a cost involved in turning, and A-star's not taking account of that. He's doing a lot of turning. Dijkstra's going, I'm going to whack it as fast as I can down here, slam the anchors on, turn 90 degrees, go. All right, so you can mess about with that if you make the map smaller. So if you look at the top, there's some keys there. So if we press F11, we can make the map smaller and smaller. F9 makes it smaller. F8 makes it smaller quicker because in tens. If you go really small to something like this and you make a map, what it actually does is it will show you all the values it's calculating for every tile. So I'm leaving it in manual mode. So I'm going to press space. That's me start and that's me end. The default to those corners, you can move them. So I'm just going to reset it with F1 and then I'm going to press space. So what it does, there's loads of numbers that we have to calculate on A star. So it puts them all in the G cost, the H cost, and the F cost. Okay. It's showing you the costs for the Dijkstra. Oh, I've still got it on 6 at a time. Let's move it down. So like A-Star found it like 16 weeks ago. Dijkstra's still going, searching the whole bloody map nearly. Nearly all the map. Okay, so you can look at it. Obviously, as you make that bit bigger, it can only, because the numbers start getting small. Yeah, 20 is your maximum size, but you can make a quite successful map with 20. Okay, I'll stop it there. Have a play about with it, and then get on with your good.